Okay, Bismillah ar-Rahman ar-Rahim. We will continue from the previous session where we broke. Now we are going to solve this problem. I just read this problem and try to explain what it means, and then we will solve this on the board. So, example 6, consider a hydroelectric project with a capacity of 120 megawatt. Average annual energy generation of 600 gigawatt hours per year, at total cost of $150 million, a construction period of 5 years with cost disbursements of 20% each year, and a useful economic lifetime of 50 years after the start of operation. The annual operation and maintenance cost, which is also written as O&M cost, will be $1.5 million per year, and the interest rate is 12%. There is no inflation. Find the average unit cost of energy. Please note one thing: when energy is already given, then we don't have to worry about 120 megawatt. Okay, unless we have to find the energy from this capacity, we don't have to worry about this capacity. Clear? So energy is already given. We are asked to find out the average unit cost of energy, so we don't have to worry about this 120 megawatt. Another thing to note is that a total cost of $150 million is given with a construction period of 5 years and cost disbursement of 20% each year. What this means? This means that if we are using the money, we use it in disbursements. We don't borrow the money, for example, $150 million in one go. Otherwise, our interest will be more. So we borrow or we use the money whatever is required in first year, and then in second year we borrow again or we use the money, and so on. So when we say it is 20% each year, the 20% of 150 is $30 million. It means we are spending $30 million each year for the construction. And once it is completed, it has economic lifetime of 50 years after the start of operation. After the start of operation, so its total life is, after the start of operation, 50 years. And then we have just O&M cost. If it is some other, for example, another power plant, it is possible that it has also fuel cost as well. In this case, we don't have a fuel cost. The salvage value is also not given, so we assume that there is no salvage value of this plant, and we are just going to find out the unit cost of energy. We could have just simply changed this little bit by giving the selling price of energy. Let's say we say that the selling price of energy is 10 cents per kilowatt hour. Then we can easily find out how much is the revenue per year, because just 600 gigawatt hour is generated each year. So multiply with 10 cents per kilowatt hour, we can find out the revenue also. And in that case, we can also ask you to find out net present value. We have discounted revenue minus discounted costs. Now in this case, we are just asking the cost of energy. The cost of energy is asking in unit cost of energy, so per kilowatt hour. This means that if we have the total numerator is total cost is there as a numerator, and total energy generated in denominator, we will find out cost per unit. Another way of doing it is by doing it on annual basis. We have annual cost divided by annual energy. it will be much easier doing it on the annual basis. The answer would be same. Either you do it from the total cost point of view, total cost divided by total energy generated in 50 years, or find the cost on annual basis. Annual cost divided by annual energy. So we already have annual energy there. All we have to do is now find out the annual cost. And we can see also that we have annual O&M cost is also there. The rest is now just we have to say how much is the annual capitalized cost. Capitalized cost is the capital cost plus the interest during the construction, IDC. If we can find out the annual capitalized cost plus annual O&M cost, that will be the total annual cost divided by total annual energy, and we will have the unit cost of energy. So let's first try to draw the what we call it cash flow diagram and then solve it. So I'm going to this is desk, okay, and we can close this one. Okay. So we are over here and we assume again the construction cost is at the end of each year. So we have 30 million here, 30 million here, 30 million here, 30 million here, and 30 million here. So we have 0, 1, 2, 3, 4, and 5 years. 5 years of construction, and at this point the power plant started its operation, and we will assume again that the O&M cost and the energy is at the end of each year. Okay, as we have been doing the assumptions before, we assume that O&M cost occurs at the end of each year, and also the energy also is at the end of each year. We could also do it at the middle of the year, but we try to keep the thing simple. So we will assume that now we have this operation has started. End of this year we have energy 600 gigawatt hour. Okay, assuming energy is of course a benefit, we can say this is energy here 600 gigawatt hour, and each year we have this energy. And we have continue with that for 50 years or so, and we have here the last. So this is also 600 gigawatt hour. Okay. So we can say 1, 2, and up to 50 years of this. We also have O&M cost, operation and maintenance cost, and as I said earlier, once the operation has started, we will assume that O&M cost also occur at the end of each year. So here the operation has started this point, and at the end of this year we will have this O&M cost here. This green color is O&M cost. O&M cost is $1.5 million. These are all in millions. Here we were asked total cost was, construction cost was $150 million, but the disbursement was done 20% each year. 20% of each year is $30 million. So we have 30 million here, disbursement, and 30 here, etc. And the last also the same way, I can write it over here. Each year we have $30 million. So this is our cash flow diagram. Any problem with that? Any clarification? No. Now, as I said, that it is easier to work on annual basis rather than bringing all the costs and all the energy at same point. We can bring this cost here at this point, and then when the cost is total at one point, then we can spread it over 50 years. And how to spread the cost, the capital cost, to the rest of its life is by multiplying with uniform annual series of payments. How do we do that? We multiply with capital recovery factor. When you multiply with capital recovery factor, it will be annualized. So first bring this cost over here at this point. Remember that we have a formula. We can actually bring this one by one also, but since this is equal payments, we can use also formula. And the formula is because from here it is a future value, so we have a future compound amount formula. Future compound amount formula is F is equal to A into 1 plus I raised to power n minus 1 divided by I. This is future value. What is A here? Annuity, which is in this case is 30. So we will multiply this with 30. I was given as 12%. A is $30 million. I was equal to 0.12, 12%. And N in this case, because we are bringing it 5 years are there, disbursement 1, 2, 3, 4 and 5. So we have N is equal to 5. And you will have the future value, which can be easily found out. You put the value here 30 and then 1.12 raised to power 5 minus 1 divided by 0.12, and I suppose, if I remember, it is $190.59 million. I think you can check it out. This will come. Okay. Any questions? No questions?
So this would be F of 5 instead of F.
Thank you very much. We have N5, so we have at 5th year, we have this cost coming. This means that now our cost is where? Where do we have this cost? At 5 here. We put this cost here. Let's we can use blue color here maybe. Okay, so the cost has come over here. $190.59 million has come over here. When we apply this formula, we have brought all the cost over here. Please note one more point. The original value capital cost was 150 million. Now we has $190.59 million. All right? This is called capitalized cost. It is capital cost plus interest during construction. Capitalized cost is equal to capital or construction cost. Construction cost was how much? 150 million. Construction cost plus IDC. IDC is called interest during construction. So we have 150 million here, and the rest 40.59 is accumulated due to interest. The total cost has become, capitalized cost has become $190.59. From $150 million, it has become $190.59 million. This cost is capitalized cost, which include construction cost plus interest during construction. Now we are over here, and this is now one-time cost, present cost we call it at this time, and we want to annualize this cost so that we can do our analysis on annual basis. Either we can do it on annual basis or we can do it on total cost basis. If we want to do it on the total cost basis, we have to bring all this spread cost of O&M over here by making present worth formula, and all the energy as well. And again, the energy will be the same way discounted. The same formula with present worth formula will be used. And then total cost over total energy. Or you will get the same answer. Or you spread this on 50 years and divide by, and then you have annualized cost. So annual O&M cost plus annual capitalized cost will have total cost. We will have total cost divided by total annual energy, and that will give us our answer. So
Would it be wiser to have a strategy first and then start solving it? You presented two strategies.
yeah.
One strategy is to bring all the costs and revenues into one place, or spread it according to an annual basis. So there are two different strategies, and based on that, solve it.
Exactly.
Another thing is that anything under the horizontal axis would be negative, and anything above the horizontal axis will be positive.
Right. All right. Thank you very much for the clarification. We have, in this case, since we are only doing cost of unit cost of energy, the negative and positive we will not worry about this time. We will have cost divided by energy. All right. But of course, this energy, if we have to multiply with let's say we are selling price is let's say 10 cents per kilowatt hour, we can easily convert to this revenue, and this revenue will be on the positive side and the costs will be on the negative side. Now we have this capitalized cost, and as I said that we can annualize it. How do we annualize? We multiply with capital recovery factor, and that will give us the annualized capital cost. So we have annualized capital cost is equal to, we have the present value, we have this one present value, and here we have the capital recovery factor. The capital recovery factor is I into 1 plus I raised to power n divided by 1 plus I raised to power n minus 1. This is called CRF, capital recovery factor. 190.59, and you can write down million if you like, multiply by, and we have this I was 12%, 0.12 multiplied by 1.12. Now here we have n. How much is n in this case? 50 years. We are spreading it to 50 years. We are going to spread this cost now to 50 years. Remember, we don't spread it by dividing by 50. Time value of money. We don't spread this cost by dividing it to 50. We use this formula, capital recovery factor, and then we annualize that. All right. So we have this over 1.12 raised to power 50, here also 1.12 raised to power 50 minus 1. And please tell me what is the number there. It will be dollar, I think 22 point something. 22.48 or something. Anybody? It would be also good if you work out this one separately. Please tell me this capital recovery factor as well.
The total is 22.95.
22.95. So we just write down 22.95 million. This 22.95 is now, this 190.59 is spread over 50 years. 22.95, 22.95 and so on. So if I may, just for your this is now spread here. This cost is now spread to 50 years, and this is $22.95 million. Clear? واضح? Okay. So we have now, this is annualized capital cost. Total annual cost is what? Total annual cost is summation of this cost, $22.95 plus $1.5 million. Okay. So what we have is how much? $24.45 million. This is total annual cost. All right, this is annual cost. Then the unit cost of energy is unit cost of energy. Total annual cost $24.45 million divided by, we have energy is 6, annual energy is 600. Now please note, 1 gigawatt hour is equal to 10 raised to power 9 watt hours, or we can also write it down 10 raised to power 6 kilowatt hours. So it is, since energy unit is kilowatt hour, we can write it down 10 raised to power 6 kilowatt hours. And since we have dollar, we may like to see the cost in cents per kilowatt hour. We just multiply 100 cents divided by $1. So now the cost will come as cents per kilowatt hour. And our answer is, if you like, is about 4.075 or something like that, cents per kilowatt hour. Any questions?
So if the utility is charging 10 cents per kilowatt hour, the utility is making profit.
Exactly. If the utility starts selling per kilowatt hour at 10 cents per kilowatt hour, it will be per kilowatt hour it will be making about roughly 6 cents per kilowatt hour. Any questions? Easy? So although it looked difficult, but it's easy, just you have to see that you bring the cost and spread it, and total cost, total annual cost divided by total energy. At home, you can try the same problem. You can try bringing all the energy at one point here and all the O&M cost here, and add this cost and divide it, total cost divided by total energy, you will get the same answer. Okay? We now move to the second problem. Let's move to second problem now. I can first clear it out. This is the solution of this problem. Okay, you have already seen this problem. We can just skip this up. Okay, let's look at this problem. A mechanical robot is part of a welding operation on an automobile assembly line costs $750,000. Its annual O&M cost, operation and maintenance cost, will be $10,000, and its expected life is only 6 years, while its estimated salvage value when retired is anticipated to be approximately $40,000. The robot will replace welding operation labor cost. If the interest rate is 20%, what annual labor savings must be realized over the robot's life to justify the expenditure? So if I may explain it again, we are going to buy a robot which will do the welding operation, and it's costing us $750,000. And there will be some annual maintenance cost also, $10,000, and maybe energy cost there. Annual operation and maintenance cost is around $10,000. And its expected life is only 6 years. After 6 years, it will be retired, maybe given to some university at around $40,000. The interest rate is 20%, or the value of money, cost of money, whatever you call it, it's 20%. Now the question is asked, for justification of this robot, how much labor cost is there, so that we can see that there is a savings in the labor, which means that the labors will be then, of course, might be used for some other purposes, or might be laid off, which we don't want. So we want to see that how much annual savings of labors will justify this expenditure. Okay. If we find out the annual owning cost of this robot, that will be the justification that if the laborers are costing us more than that of annual owning cost of this robot, then it is justified, otherwise it won't be justified economically. Of course, we are talking about economics only, we are not talking about any ethics here. We don't want that laborers be replaced with robots, right? But this is going to happen anyway.